In this video, we're going to talk about functional groups, which are also sometimes referred to as reactive groups. A functional group is a group of atoms that are part of an organic compound that react in a particular way. So a few things to review include what an organic compound is. And an organic compound, remember, by definition, is just a compound that contains both the elements carbon and hydrogen. So it must contain those two elements. And organic compounds come in a lot of different shapes and sizes, and then these functional groups might just be part of the atoms making up this kind of larger organic compound. The functional groups that we are going to look at in more detail in this video are going to be the hydroxyl group, carbonyl, carboxyl, amino, sulfhydryl, and phosphate groups. And we are going to pay especially close attention to the hydroxyl, carboxyl, amino, and phosphate groups. Starting with the hydroxyl group is a fairly simple group of atoms. It's made up of an oxygen bonded to a hydrogen, and that's it. That is the hydroxyl group. Now, you'll notice that we're going to put the letter R kind of right here, and I'll draw a little box around it. And this R is just kind of a generic placeholder. So this generic placeholder is just for the rest of the compound, because this hydroxyl group can actually be attached to a variety of different organic compounds. So let's take the example of glucose. So if we look at glucose's molecular formula is C6H12O6. And if we were to draw this out, it would look like this. So this is what a molecule of glucose looks like. Now you'll notice that we have several different hydroxyl groups on this molecule of glucose. So anywhere where we see that OH is going to be our hydroxyl group. And then the rest of the molecule, so all of the rest of the molecule that's not made up of that hydroxyl group, or of the different hydroxyl groups, we would just replace with that R as a placeholder. The hydroxyl group is oftentimes also just abbreviated as -OH. The carbonyl functional group is a carbon double bonded to an oxygen and then single bonded to a hydrogen. And remember that we have this R placeholder here that refers to the rest of the molecule, because a carbonyl group can be attached to a variety of different organic compounds. But the part of the organic compound involved in its reactivity is going to be the carbonyl group, which is just the carbon double bonded to the oxygen and single bonded to the hydrogen. So an example of a molecule that has a carbonyl group would be glyceraldehyde. And glyceraldehyde looks like this. Now, in this molecule of glyceraldehyde, we can see that carbonyl group is the carbon double bonded to the oxygen and single bonded to the hydrogen. So this would be our carbonyl group here. Now you may have also noticed that we have our hydroxyl group also found in the same molecule, because remember OH is our hydroxyl group. So this is a great example about how an organic compound can have more than one type of these reactive groups. Now the rest of the molecule is just going to be that R placeholder, because we could switch this out with a different organic compound and still maintain those reactive groups and still have that reactivity associated with it. The next reactive group is the carboxyl group, and carboxyl is just that placeholder R bonded to a carbon, which is double bonded to an oxygen, which is then single bonded to another oxygen, which is bonded to a hydrogen. Now, don't get the carboxyl group and the carbonyl groups mixed up, because remember, the carbonyl group is that R placeholder with a carbon, double bonded oxygen, and single bonded hydrogen. So you can see the difference is really here between the carboxyl and carbonyl groups. Also, don't get it confused with the hydroxyl group, which is just that placeholder bonded to an oxygen, bonded to a hydrogen. So once again, the hydroxyl group looks like it's actually in the carboxyl group, because if you look at that OH here, it looks like it's that same OH there, but the key difference is that carboxyl also has this carbon bonded to that double bonded to that oxygen. So make sure you don't get these three confused, because they look very similar to each other. Now this carboxyl group is sometimes also just abbreviated as COOH. And let's do an example of a compound that has the carboxyl group in it. So we're going to look at an amino acid known as glycine. And glycine is a fairly simple amino acid that looks like this. And hopefully you can pick out in this molecule here where that carboxyl group is. And so we've got our carbon double bonded to our oxygen, which is bonded to an oxygen and a hydrogen. So remember that this is the carboxyl group, but there is not a hydroxyl group. So this OH here is not hydroxyl, it's just part of carboxyl. Next, we are going to talk about the amino group. So once again, we're going to put our placeholder in there for R, and then the amino group is going to be a nitrogen bonded to two hydrogens. And sometimes it's abbreviated as just dash NH2. And for an example, we're actually going to use the same example we used for carboxyl. So once again, if we look at that amino acid known as glycine, we can draw it like this. So there's a carbon with that carboxyl group attached to it that we talked about on the previous screen. And then that is bonded to a nitrogen, bonded to two hydrogens, that's our amino group. And then the central carbon has some hydrogens attached to it as well. So in this example here, we have our amino group as our NH2 on one end of the compound, and then we have our carboxyl group on the other end. So we have an amino group, but we also have a carboxyl group. For the sulfhydryl group, we have our placeholder bonded to a sulfur atom, which is bonded to a hydrogen atom. We can also abbreviate this as just dash SH. An example of a molecule that contains a sulfhydryl group is going to be another amino acid, this time called cysteine. And so here's what the molecular formula of cysteine looks like. Now, cysteine is interesting because it actually has three functional groups present. So it has the amino group, which is that NH2. It has the carboxyl group, which is the COOH. And then it also has the sulfhydryl group, which is just the SH. And then this middle portion here would just be that placeholder or that R. So it could be cysteine, but it could be a different organic molecule that's actually making up that kind of core skeleton. And then the sulfhydryl is just kind of sticking off to one side, and it gives that molecule properties and it allows it to interact with other chemicals in a certain way. The last group we're going to talk about is the phosphate group. So once again, we can put our placeholder with the R just to kind of signify that there is some organic compound with carbons and hydrogens over there. And then bonded to that placeholder, we would have an oxygen bonded to a phosphorus, which is double bonded to another oxygen, and then bonded to an oxygen and a hydrogen, and then another oxygen and another hydrogen. Now, it's important to note that these OH groups, once again, are not hydroxyl groups. They are part of the phosphate group. Examples of molecules that have phosphate groups are going to be nucleotides. And I would try to draw out a nucleotide, but it would take up this entire screen. It's a pretty big molecule. But to give you an idea, a nucleotide typically has a 5-carbon sugar, a base attached to one side, and then the phosphate group is attached to the other side. So we'll talk a little bit more about the kind of the overall structure of a nucleotide in a different video, but just know that the nucleotides have a phosphate group attached to them. So in summary, we learned about different functional groups that are attached to organic compounds. And the main kind of feature of these functional groups is that it gives these different organic compounds different properties. And the different properties that these organic compounds might get include things like reactivity. It can also affect whether a compound is polar or nonpolar. Which directly affects whether it is hydrophobic or hydrophilic. Now, in another video, we're going to talk a little bit more about this reactivity. And when we talk about this reactivity, we're going to talk about some chemical reactions known as dehydration synthesis, and hydrolysis. So when you watch that video, think back to this video and think about those functional groups that we talked about, and we'll see how they are involved in having or allowing these chemical reactions to occur.